Hey, Steve with Trimble and the Building Point teams. This FieldLink tip number 16 is going to be ACI tilt-up analysis. You can make sure that your walls are within spec. We're going to be using FieldLink to do some in-field workflows as well as do some deliverables created from RealWorks. So as you can see here, this is the wall we're going to be analyzing, as well as some of the gap analysis we'll be doing between the panels, verticality, over one, over all of them, and then show you some of the other deliverables we can create. So refer to your contract specs, structural engineer, and ACI tolerances to actually get these specs. But we'll look at verticality. Generally, that's going to be about a 1/2 inch wall lean. FFFL is generally done before it is tilted up, but you can do that with FieldLink and with RealWorks. The one we'll probably jump into first is actually gaps and joints between each panel, making sure it's underneath that 1 inch max, or maybe it's a 1/2 inch. And then panel thickness and reinforcement can be done pre and post. Post if you scan both sides of the wall, or pre if you essentially scan before it's poured and after it's poured. And then embeds and connection locations can also be analyzed and compared to a model. This is generally done with a little bit more ease if you have a model, but you certainly don't need one for a lot of that analysis, like verticality. You really don't need one. So jumping into it, FieldLink. So let's actually turn this off. So here we have a number of scans collected. We can actually see them all here if I turn them all on, going down the wall. Now, the reason for these multiple layers of scans is to actually look at the gap analysis. So to do that, you're going to want to actually be pretty much head on so that you can take the measurement from each side. To do an in-field gap analysis, it is probably best to A, collect your scans, B, make sure that they refine well, which these have. Here you can actually see that. Pretty good analysis, obviously very good overlap, so we're going to have that done pretty well. But then after you refine and collect, or if you just do a gap analysis, you really only need 2 scans. You can go ahead and jump in to a section box, extract out the full density of these points. And what this is going to do is bring in all the scan data from that cloud rather than just a preview scan data. Moving through here, I can actually look at different areas, but what I'm going to do is actually segment this down. So when I do kind of a distance analysis between these two, I know it's essentially pretty close to that. So here you can see that's about 7/8, probably within tolerance if it is 1 inch. But as I move up this wall, you can actually start to see where it starts to go out a little bit. So pretty quick to do that. Over here, 13/16. So I may be, actually let's do this. Maybe a little concerned, but depending on what that analysis or what that distance is, I can actually, what the tolerance distance is. If it's over a 1/2 inch, I would say that is definitely out and they're going to need to fill it. So I'd have them fix this portion of the tilt up wall. Pretty easy to actually see that, and then go through. The other thing you can do within FieldLink is just do, let me turn the scans back on, verticality measurements with just a measure. So to take those just initial measurements, you can actually come in here, just select the measurement tool, and then usually I like to do something fairly far apart and then with a little bit of gap so that I can see, like this is actually showing me it's closer to 2 inches out in the X direction, which is the in and out of that wall. The other thing and the final thing we can do for a field inspection is if I have a model, which I do here, just a simple plane, you can actually see that there. We'll turn on the solid model so you can see it. It's just a vertical plane. I can run an inspection, and what that'll look like is once I have it turned on, I probably should do this, which is create a little section box around it and then run that inspection. It'll compare the scan data to the nearest model data. So if I turn off the solid model, I can actually see where it's starting to lean out and where, again, that is essentially leaning in quite a bit. So if let's actually bring this over so we can start to see that area of issue, which would be right about here. And then let's turn the model on so that I can confirm what I'm seeing is right. So let's turn off the section box real quick so I can make sure I'm on the right side of this. Yeah, that's where this is where it's at. Turn this back on, bring this over again. And from a side view, this would be where the scan is. And here's the wall. So it's actually leaning back, not in. Well, I guess into the building. So with that, if I wanted to, I could share the scan inspection. I can actually export with those colors as an E57 LAS that can then be brought into AutoCAD or Revit to kind of give if I'm the GC, give it to the wall contractor to show essentially the exact as-built points of the wall. The other thing I can do to share analysis is if they don't just want the RCP, you can send specific points. Like we'll do that gap one more time, which I believe was this one. I can do specific points from this scan data, come back up here and create them. So I can create a point and then create a point, which essentially will represent this line that can be exported out as a DWG. So if I did those analysis, and usually it's not every gap's going to be an issue, not every wall line's going to be an issue, I can send just that. Be a little bit clearer because it's just essentially DWG of stake points like that. Same thing with the wall analysis we did, or the lean analysis for the smaller section. Over here, I could create a point on each surface, and then one down here. And again, that will essentially communicate back to generally a little bit easier or simplified program. If they don't want the full point cloud, you can send just those points and show it in and out. Plus they have X, Y, Z coordinates, so within the project site, you should know exactly where that's at. Now moving into RealWorks, where we can do quite a bit of an analysis, you can see to do that, I would actually export a TDX, so scan, export, TDX, just like that. That'll send all the data registered and refined. Since I did that in FieldLink, I could use RealWorks to do some more registration analysis or some more registration if I didn't like the plane-to-plane that was created by FieldLink. But if I just did the refinement, it should match, and the refinement numbers and report were good. So I'll pretty safely assume that we had a good registration out in the field. In RealWorks here, what'll generally come in as a full cloud like this, I'm then going to want to essentially break it up and segment it into those areas I want to analyze. So here you can see I've already segmented out one little gap of that wall, so I can just focus on an analysis here. I'll turn off the rest. Here we actually already did a wall analysis as well as kind of inspection that we're going to show you how to recreate, so that I can show you how to get these lines, which is essentially a flat wall comparison to the scan data, so just a vertical wall analysis, and then that kind of gives me a pretty good start. And these blue lines are actually representing where the kind of at a segment or an interval I selected, which is about 6 feet. The distance, so you can kind of see the chamfer and then the actual distance between those two. I can export those out along with those measurements that you see here as 1 inch, 1 3/8 inch as a DWG. But this is generally a nicer reporting structure just because it can kind of make a little more sense as far as just intervals rather than the full point cloud. So moving into that, we'll go back, select the the point cloud that we want to analyze and go into inspection, wall verticality analysis, and move our way into that. So I can fit a vertical plane to the full wall or just the segment, which is generally what I'll do, because what that'll do is essentially allow me to select something probably close to the ground that will better fit it. So we'll do that here by essentially selecting one wall, fit it, and that'll essentially create a plane to that. And then I can generally assume that something near, if I wanted to, I could create a plain wall, or I could assume that that wall is where I want it to be. So I'm going to use that smaller section to kind of define the plane. I could go through Geometry Creator and actually do it just a verticality wall, or just bring in a meshed wall as well. So with that, I'm done. Here we can set our grid spacing. So I have a vertical wall that I defined down here. I did the analysis actually all the way up through the structure, and then I can set a grid spacing of 1 foot, so it'll actually analyze it per 1 foot. Because I'm doing the kind of gap, I'll actually do this a little bit smaller and do 1 inch so that I can grab some analysis within there. And then my outer tolerance, we'll say, is 1/2 inch lean in and out. So here you can see that the wall is pretty vertical. Everything's within 1 inch lean, except potentially at the very top. But then you can see where this is blue, because obviously inside that is where the walls are coming together. Create a report for that. This would actually be the same kind of analysis I do for verticality of one panel, because I'm just doing a gap analysis or joint analysis. I'll create the inspection, and what that inspection map is going to allow me to do, if I come in here, is to select it and do an inspection map analyzer. And so with that inspection map analyzer, you can actually see here, this is showing me the deviation of those points in and out. Let's see if I can find this going all the way up. I can zoom in here. I can actually start to see where it's bumping in and out. And by creating that line, that reference line to the wall, I can then see where the gap is and kind of see where that chamfer edge is coming in and out and where I'm looking at there. So you can see that. And then I gotta find, and here I found essentially that scatter plot showing me this would be the joist, or the joint, and then I can start to see like the distance and gap there. But to do multiple slices, I'll do it every 6 feet. Make sure that's 6 feet. It'll actually run through, but if I create all these, I will have DWG lines actually showing me that. And let's close this and actually show you. And actually, before we close to show you that, I could do an ISO curve to do contouring. But closing this, I have all these map sections already created. I'll turn them on, turn off the inspection map, because I think it's a little bit clearer to show you from here. This is a top-down view of that. Usually give me a better analysis of, by looking at this, I can kind of see where that chamfer edge is starting to stop in there. So I could then come in here and then take measurements from that, or even from the DWG points, and then download that. So about 15/16 for that width distance. So if it was a 1/2 inch, that would definitely be out. If it was an inch, we should be all right. Going up through here, I could do that going all the way through. So the one deliverable there is, I think, really nice for like a joint analysis. We're going to go ahead, that's about another inch. I'm going to bring these actually back in, so those measurements back into the wall inspection. I could export those lines, the reference, which would be the red line. The green is actually the scan data showing you the in and out, and then what the blue shows you is the width of that joint. and then I could go and add in some more specific measurements if I wanted to communicate where it is. Export them as a DXF. They'll come into CAD or Revit in the right location, because you should georeference your scan data to that model before, so everyone knows what we're looking at as far as the issues we're seeing. So the next one we're going to cover here is we'll turn these off and we'll move back to, we'll do a full wall. I guess this one. And I can do if I can bring in a model, I actually don't need to create it. I already have one that I've created, but I can do a geometry creator and just create a plane. So that's completely vertical. And generally, a verticality analysis is going to be ran per panel, and you get 3/8 of an inch between each panel. But because I already have the plane, I'll actually just use this one. I could do the same wall inspection to do that, either per panel or per the entire wall, and run the same reporting with the same rather than what I want to say horizontal analysis. I could run it vertically to show that, or I could just pretty quickly come through here and run a scan to model inspection, just like we did in FieldLink, to get a colorized analysis of where it's leaning in and out. And going over a couple wall sections, you will start to actually see the same walling we saw before. So that can be created. Now, doing a panel inspection for a wall verticality, we'll actually come back through here. I'm going to copy it and then rename this. We'll do this panel, or we'll wait until we're done segmenting to do a panel 1 analysis. So here I'm just going to select this one panel, clean it up, keep that, close, and then here's my panel. We'll call this K, just for annotation. And then I can go into the wall vertical analysis. Again, this is kind of like that joint analysis we just did. Actually, it's going to be the same tool, but we'll show you some of those other what the deliverables look like when you're looking at just a vertical analysis. So here, we'll select panel down here as far as an alignment. Where's that define area? Make sure I'm not over the joint there. And then rather than 1 inch, that it would be much too dense, we'll go 6 inches. Outer tolerance still 1/2 inch, and then we'll start to see it. So let's turn off the grid. You can actually start to see where it's leaning a little bit at the top there too. But everything else is within, obviously, besides the joints and kind of the aesthetic cuts that they have in there. So I can actually create this report. So we'll call this panel K. And this would be a pretty good deliverable, showing you that image. And then that image is actually will give me that full report. Another TIFF image where I can start to see the lean in and out of that. I should actually have a nicer one here. Yeah. So here is the TIFF image of that, showing you the deviation from the wall there, where red would indicate it's over 0.5 of an inch or 1/2 inch out, leaning in. So that's pretty good. Actually, this would be leaning towards the scanner, so outside of the building, and the blue is obviously those cut or aesthetic cuts that are inside. Again, after that inspection map is created, I can come in here and do a similar inspection map analyzer. But rather than going horizontally, I can go vertically to kind of capture what's happening up there. We'll try and find this one down here. So let's swap axes. So I'm at 0 and 196. And then I can even set scales. So horizontal scale, vertical scale there will actually and let me play with that again. I don't like that. Keep playing with that until we see what we want. And so playing with scales here, we can actually see that is essentially representing the scan data compared to the plane being fairly close here with a 1-inch scale. So this would be about a 1/4 inch here to about that 1/2 inch lane that you see at the top. As we move through here, you can actually see where that changes, and then where right here you can see it actually coming in a little bit higher on the end there, or a little bit more of a lean back, and then as you're moving through the outside of that wall, it's actually all good. So I can create those same lines again, or export them as well too. And the other thing I can do, rather than just doing kind of the vertical wall analysis, is do a contouring map, which can also be pretty nice because it's a little bit easier to interpret what the deliverable is there. Those section cuts are going to give me very precise differencing. Contouring will as well too, but this is sometimes a little bit easier to read just because people are a little more familiar with what that looks like for a contour. Let's do 4/16. And so here you go. There's your contouring map. So I could create that as well too, and export those contour lines as a DWG as well too. So those are your very specific wall analysis, doing leaning in and out, vertical analysis of that. We did some joint analysis there as well too. The only other thing that we didn't cover, because we actually don't have the model today, is if I wanted to do kind of like an embed or cutout analysis, I could do that to the model, or I could just even create these points, these lines, or even specific points that I could export to make sure that they're all in the right spot. I'd probably want to do an embed analysis or a cutout before I poured, just to make sure they're there, but I could do it afterwards to catch if anyone's wrong. I could run that same inspection in FieldLink, or do kind of a little bit better of analysis there with some DWG lines and specific points that can be exported in RealWorks here. So thanks. This is a lot to cover, but there's a lot to do. Talk to your structural engineer about what the specs are in your project manager, scan it, and then you can run through that analysis and actually make sure everyone's within that 1/2 inch or inch, whatever the spec is, to make sure it aligns well.